Hey guys, and welcome back to my channel. This is a quick demonstration video. The question that was asked by one of my viewers is, can a Caline power supply be able to supply enough current to run the HX Stomp multi-effects pedal from line 6 by use of what's called a current doubler adapter? We have this adapter here. It looks like a Y adapter. You have two male ends and a female end, and what the idea behind it is that you can only power up to 500 milliamps on these two outputs here, and if you connect them together to run them in parallel, then you should be able to get up to 1,000 milliamps of draw at 9 volts. And according to the spec and to some of the videos that I found on that particular pedal, it takes anywhere from 800 to 1,000 milliamps at idle, which is a pretty power-hungry pedal. The original power supply that it comes with is actually rated at 9 volts and 3,000 milliamps or 3 amps. That is a very significant overbuild to be able to power that pedal properly, because you need to be able to not only provide sufficient current, but you also need a very thick wire in order to prevent voltage drop as it gets over to your load. What I have here is a demonstration of the current draw of the CP-206 and then other pedals like that from Caline. This is not the best application, and I will go into here to why that is. But let's just try the 500 milliamp line. I have a parallel setup here. I'm measuring the voltage right at the source of the power supply, so we're getting 8.97 volts out. We have two 10 ohm resistors. I'm going to connect in series for 20 ohms. That should give us about a 420 milliamp draw. And I want you to watch the voltage meter here, and then here's the current meter. So we'll connect them together. So you're seeing we're drawing about 420 milliamps, and you see that the voltage drops down to 8.69, call it 8.7 volts. And that is acceptable for the type of topology that we're working with here. It's the linear voltage regulator inside that's taking higher voltage coming inbound and regulating it down to 9 volts, but that extra power is going to be wasted as heat through the linear voltage regulator. We don't want that linear voltage regulator to get too hot, so what they do with those types of circuits is that there is another resistor in series with this output. So in the event that you go and you short circuit it, you know what you're going to do, you're going to see that it's going to go off like that. It's going to draw too much current, but rather than put that heat into that linear voltage regulator, that resistor inside is going to protect it. But having that in place also means that you are going to lose voltage at your pedal when you start drawing closer to full load. It is not the best application for high current applications because of that design. And there's nothing wrong with the pedal power supply. It just was not intended to run high current power. So now what we're going to do is we're going to go and hook up the two 500 milliamp lines in parallel, basically replicating what this current doubler adapter would do. And what we're going to do is we're going to just use one of the 50 watt 10 ohm resistors. So 10 ohms at 9 volts is going to give us about 800 milliamps of draw. And again, watch the voltage meter as I hook this up. And you can see that we're drawing about 830 milliamps from the two lines there, and you are dropping down to about 8.64 volts. And again, that is acceptable for this type of topology. You don't want to draw, it's not supposed to drop any further than 8.6. But this is, again, the issue that you have with running high current pedals. You would have to go and add more of these outputs in order to combat the voltage drop that would inevitably happen on a high current application. Your wires are also going to need to be significantly oversized in order to handle that current, because by the time the voltage over here is 8.6, your voltage over here at your pedal is going to be significantly less. All right, guys, I'm going to end the video here. If there's any questions, please let me know. But thank you again for watching and supporting the channel, and see you on the next video.